Так. Мархамат, Алишер. Давайте.
Good morning, dear members of the seminar. Thank you for giving me a chance to present my talk in this seminar. Today I'm going to talk about Denjoy equality for circle homomorphisms with two breakpoints. Let me start my talk with very basic notions of circle homomorphisms. We consider a unit circle where we identify 0 and 1 as a 1 point. The map F is called circle homomorphism if F is 1-to-1 on the circle and if F and its inverse are continuous on the circle. The circle homomorphism F is called orientation preserving if we are given 3 points x, y, z which are oriented on the circle, implies that fx is less than f of y and less than f of z. The function capital F satisfying the following two properties, which is capital Fx is strictly increasing and continuous on R, and f of x plus 1 is equal to f of x plus 1, is called lift of orientation preserving circle homomorphism if the fx is equal to fractional part of capital F. Note that if f1, f2 are lifts of the same homomorphism, then they differ by some integer k. And if capital F is a lift of some homomorphism F, then its nth iteration, here we are considering as Fn is nth iteration. So nth iteration of capital F is also lift of Fn, F to the n. All homomorphisms F to the nx have the same property with the homomorphism F itself. Now let me introduce the notion of periodic point. So let given function g maps m to itself, and the point x0, x0 from m is called periodic point with period k if k's iteration of x0 is equal to itself and all other iterations less than k are distinct.
So Alishar, I have one question.
Yeah.
Go to the previous page.
Yes.
So when you definition 2, orientation preserving. So
yes.
For 3 points, but is it the same if you take that monotone, that if x is less than y, then f of x less than f of y?
Yes.
More, it is the same, or it's more stronger condition?
It's more stronger because if we consider just 2 points, so since we are considering unit circle, so we identify 1 and 0 as a 1 point. So if we take, for example, x as a 0.5 and y is as a 0 point, we can take y as a 0.8 or y as a 0.3. So, but when just here we are considering as just orientation, location. It's a little bit different with the less as a value. Bu yerda faqat joylashuv orientatsiyasi.
Kuchliroq shart ekanda bu.
Kuchliroq shart. Misol uchun x ni 0.5, y ni 0.8 deb, z ni 0.2 deb ham olishimiz mumkin. Bunda aylanib qaytib kelaveradi. Of course, orientation is considering the counterclockwise. So we consider positive orientation as the counterclockwise direction.
То есть soat ilmiga qarshi.
Soat ilmiga qarshi direksiya. Counterclockwise.
Понятно. Ладно, go on.
Okay, so when gx0 is equal to x0, then the point x0 is called fixed point of the map G. Now let me formulate the fundamental theorem of point array. Let F be orientation preserving circle homomorphism and capital Fx is its lift function. Then for any x, this value, the limit exists, and this limit, it does not depend on the choice of x. and this limit is irrational if and only if when f has a periodic orbit. So if we take the fractional part of this limit, then it's called a rotation number of circle homomorphism f. So in this slide, we consider the continued fraction, so expression of the continued fraction of the irrational number, irrational rotation rho. So circle homomorphism f, homomorphisms f and g are called topological conjugate if there exists homomorphism p such that satisfies the following relation. And the irrational rotation number rho f is invariant under topological conjugations. Let's consider the continued fraction expression of rho, and let us denote by Pn over Qn, just n's convergent, where Pn and Qn satisfy these recursive relations. And Qn's are called first return times of homomorphism f. Now let me introduce p homomorphism classes. The natural extension of circle diffeomorphisms are piecewise smooth homomorphisms with breakpoints. Shortly, we call them as a p homomorphisms. The p homomorphisms, the class of p homomorphisms, consists of orientation preserving circle homomorphisms which are differentiable except at finite or countable number of breakpoints. So breakpoints, which means that their one-sided derivatives exist but do not coincide, and for which there exist two finite constants, such that, so if we can see that the one-sided derivatives of the breakpoints are bounded by C1 and C2, and all non-breakpoints also bounded by C1 and C2, and the total variation of logarithm df is also on S1 is also finite, and the ratio of the one-sided derivatives is called jump ratio, which we denote by sigma f. And if we the product of all the jump ratios is called total jump ratio. Here, let me introduce the Ehrman's map. Ehrman, in his book, introduced piecewise linear homomorphisms with two breakpoints, which he in his book studied invariant measures of the PL homomorphisms and regularity of the maps conjugating to p rotation, the linear rotation. And this is the formula 1 is Ehrman map. Here lambda is bigger than 1 and beta is positive. They are parameters. And here we can see Ehrman's map, the graph of Ehrman's map, and here 0 and C are breakpoints. And Ehrman considered one parameter family, small h, beta, lambda, theta homomorphisms, which is this is just capital H plus theta mod 1. Mod 1 is this fractional part. And clearly, I also showed now, clearly breakpoints of this map, 0 and C. I want to mention one thing here, that breakpoints of capital H and small h are the same. And these small h are called Ehrman maps. This is a graph. And before formulating the Ehrman theorem, let me give some needed notions. So piecewise linear circle homomorphisms are just simplest examples of p homomorphisms. They occur in many other fields of mathematics, such as group theory, homotopy theory, logics with function groups. And PL circle homeomorphisms with two breakpoints considered first by Ehrman, and to obtain the homeomorphisms of arbitrary rational rotation number which admit no invariant probability measure equivalent to Lebesgue measure. Here the definition, let me use the definition. Let in the X be the measurable space, define two probability measures, mu1 and mu2, and the measure mu1 is called absolutely continuous with respect to the mu2, measure mu2, if for any measurable set A from B, which the A is measure zero, set respect to mu2 implies that the measure of A respect to mu1 is also 0. Let XB be the measurable space, and measure mu1 is called singular with respect to the measure mu2 if there exist two disjoint sets A and B whose union is equal to the whole space, such that mu1 is 0 on all measurable subsets of B, while the mu2 is 0 on all measurable subsets of A.
So this definition is symmetric. So if mu is singular with respect to mu2, then mu2 is singular with respect to mu1, yes?
Yes, of course, yes.
Because definition is symmetric.
Yes, yes, exactly. Now let me formulate Ehrman's theorem. So, but here we need invariant measures. So definition of invariant measure is following. Let the X be mu be probability space, then the probability measure mu is F invariant if the measure of A is equal to the measure of its true image for any A from the sigma algebra. Now formulate Ehrman's theorem. Let H be PL homeomorphism with two breakpoints and irrational rotation number rho. Then H invariant probability measure mu is absolutely continuous with respect to Lebesgue measure L, if only if its breakpoints belong to the same orbit. Otherwise, it's singular. We denote, furthermore, we denote by H Ehrman maps, PL homeomorphisms. So the invariant measures of piecewise smooth homeomorphisms, P homeomorphisms, with finite number of breakpoints were studied by many authors, such as Ehrman, Euler, Lewis, Nakada, Jalilov, Meyer, and so other scientists. Jalilov, Meyer, and Safarov, in their work, they proved that the invariant measures of P homeomorphism F with rational rotation, rho, and non-trivial total jump ratio from the class 2 plus C2 plus epsilon are singular with respect to the Lebesgue measure. In this case, in their case, phi, the conjugation between P homeomorphism F and linear rotation F rho is singular function.
Here Jalilov means Akhtam Jalilov, yes?
Yes, yes, yes.
Not you.
So Professor, he in his in English, in his surname, the DZ, little bit different, Jalilov.
Okay.
So here, for more information, I gave the definition of the singular function. Now, let me introduce our main object, Denjoy inequality. The study of the behavior of df, the derivative of the dfqn is classical problem in the theory of circle homeomorphisms, which plays key role for their dynamics. And these authors also dealt with they also studied the behavior of derivative of dfqn. Now let me recall two Denjoy's classicals which are generalized to P homeomorphisms. The first is about the bounds of the FQN, which is proved by Ehrman. Let F be P homeomorphism with irrational rotation rho, then for any x which is not in the orbit, which is not a periodic point, then the following inequality holds. Here V is total variation of logarithm df. And this
is result. So in presentation, it's better to give references on the same slide.
Yes. So this one, sorry, I gave the little earlier. So uzr domla, men aniga har safar berish shart emas deb o'yladimda. Bu anaqaniki Ehrman kitobidan olingan, Ehrman resulti bu. Denjoy tengsizligini ikkita sinish nuqtasiga ega bo'lgan pi homeomorfizmlar uchun обобщение.
O'shaning uchun o'sha slaydni bersangiz tushunarli bo'ladi. Nima edi deb odamlar o'ylab o'tirmaydi. Qaysi maqola edi, kim topiydi deb.
Tushundim.
Keyin mana bu termini formulovkasida mana bu roni fiksirlayapsiz, как бы lekin nimasida ishlatmayapsiz. Shuning uchun balkim ro masalan rotation number ro deyapsiz-da, mana bu pastda ishlatilmayapti-da bu ro. Balkim
endi domla bu yerda demak hammasi ro irratsional bo'lgan holda ko'rilgan, sababi ro irratsional bo'lgandan keyin
demak irrational rotation irrationalligi muhim, lekin uni olib shuni aytasiz. Nima shartida irrational?
Roni olmasdan просто with the irrational rotation number getsin.
Tushundim. Ro shart emas. And this inequality 3 is called Denjoy's inequality. So here the second theorem is also a very important theorem in our work, in our result. So if Denjoy's inequality holds for the map F for P homeomorphism with irrational rotation rho, then F conjugates to F linear rotation F rho. And phi is also so-called homomorphism here, the conjugation between F and F rho. And now let's consider the orbit of x0. This is the orbit of x0. It is full orbit because if you see I is just an integer. And now let me formulate the following theorem, which is also proved by Ehrman. Let F be P homeomorphism with irrational rotation number. Then for any n, this integral is equal to 0. And now our main goal in the present talk is to express for piecewise linear homeomorphisms. Later we call it just Ehrman maps with two breakpoints A0 and C0, and total jump ratio is equal to 1. The derivative of the derivative of f of h to the qn by the jump ratio of the breakpoint A0 and the invariant measure mu, so of the intervals of break points, which is determined by the breakpoints of f to the qn. And to start, let's fix one point x0 and consider its orbit, and we denote by I and 0 the closed interval with endpoints x0 and xqn. And when n is odd, then the xqn is located to the left side of x0 on the circle, and when n is even, it's located on the right side. And denote by INI x0, I is just I is iteration of IN0, and then consider the set C and x0, which is the union of just two type of intervals, which determines the partition of the circle and is called nth dynamical partition of the point x0. And in the transition, this said in the transition n's dynamic partition to n plus 1's dynamic partition, all small intervals in's are not, so they don't change, and the big intervals in minus 1, they be divided into kn plus 1 intervals by the following way. So kn plus 1 is just coefficient of the continued fraction. Now let me introduce the breakpoints of f to the qn. We know that a0 asterisk and c0 c0, they are the breakpoints of f, and we consider so which they are not in the same orbit, and we denote by pn over qn the partial convergence of rotation number, and we determine the location of the breakpoints at qn and the derivative of fqn on the circle. Obviously, the breakpoints. So fqn has two qn breakpoints, and we denote by this set by bpn, which are the union of two sets. So here just we distinguish it. Just let's call it type A and type B. So then all breakpoints generated by A0 and all breakpoints generated by C0. And this the partition Bn of the circle consists of two qn intervals. So they are pairwise disjoint, but they just intersect by their endpoints. Now we consider the breakpoints case by case. Let location of the breakpoints case by case. Let Cn be n's dynamic partition determined by the one breakpoint A0, and then the other breakpoint C0 is located on the circle, one of in these three cases. And now let's see the location of the breakpoints of f to the qn in each case. Consider each case. This is the case 1, like this here in the case 1. So assume C0 belongs to this interval, then the breakpoints of fqn are all belong to the following intervals. Here you can in the graph, these are all just elements of the dynamic partition Cn here, and we can see the location of the breakpoints. All here we consider all location, all breakpoints, location of all breakpoints in the case 1. Now let's consider the case 2, where when C0 belongs to this interval, and the breakpoints of fqn belong to the following elements of the partition Cn C minus I0. I want you to make attention here. We are considering another partition, C minus I0's partition, n's dynamic partition, and belong to the all intervals of this partition. And here we can see the location of all breakpoints of f to the qn on the circle for the case 2. Now this is the case 3, when the C0 belongs to this interval, then the breakpoints of fqn are located in the elements of this dynamic partition. Here also we are considering different dynamic partition of this dynamic partition, the elements of this dynamic partition as following. And this is the graph here. So this is the dynamic partition of A minus qn plus 1, and this allocation of all breakpoints for the case 3. Until now, we considered the 2 breakpoints in the different orbit. Now, let's consider when the breakpoints are in the same orbit. For example, one breakpoint, if we take as a consider as a breakpoint A0, and the second breakpoint is I0. So just I0 is iteration of A0 in the same orbit.
Here should be a C0, yes? F.
Yes.
C0.
So, but it's after the I0 iteration, it comes to the C0. Yes, it should be C0. Sorry, here there is a misnotation, so there is a type mistake. And assume that n is bigger than ni0, then total jump ratio sigma is equal to 1. And clearly FQN has 2 I0 breakpoints when they are in the same orbit. And here they given all breakpoints when they are in the same orbit. And if total jump is not 1, then F to the Qn has Qn plus I0 breakpoints, which are the following. And here the locations of the breakpoints in the case when the breakpoints are in the same orbit. Let F is a p homeomorphism with irrational rotation number ρ, and 2 breakpoints are in the same orbit. Then if jump ratio is equal to 1, so we choose n. So first one, if jump ratio is equal to 1, then this is the location. So all breakpoints are belong to this interval. And if jump ratio is not equal to 1, then all breakpoints belong to these intervals of the dynamic partition of A0. And here the graph of the case when they are in the same orbit. And so all lemmas which we have considered above show the location of breakpoints of F to the Qn on the elements of n's dynamic partition determined by F. Now we apply the lemmas, all the lemmas, to Ehrman maps, to piecewise linear homeomorphisms with irrational rotation number ρ, when 2 breakpoints A0 and C0 are not on the same orbit and total jump is equal to 1. And in the case lemma 1 and lemma 3, which are the case 1 and case 3, so the breakpoints originating from A0 and breakpoints originating by C0 are alternate. The location they alternate in their order along the circle. And just for the simplicity, let's consider assume that n is odd number. Then these breakpoints define a system of disjoint intervals, which are given by formula 5 and 6. And if we combine all these intervals in the 5 and 6, then and we denote by an and bn, union of these intervals, then in the case lemma 3, we denote the intervals with endpoints, which are endpoints are breakpoints 7 and 8, and we combine all these intervals, take the union, denote by an and bn, and then we can formulate our first main result for the case 1 and 3. Sorry, here I wrote 2, but this is case 1 and 3. Let H be Ehrman map with irrational rotation ρ and the 2 breakpoints A0 and C0 whose total jump is 1 and which lie on the different orbit. And then for the case lemma 1 respectively, so the derivative of H to the Qn is equal to these 2 values. And for the case 3, derivative of HQ h to the qn is equal to these values. And for the case 2, we determine we denote by in and bn this union of these intervals. Again, here we are taking the intervals when the endpoints are breakpoints, and we formulate our second main result. Let H be Ehrman's map with 2 breakpoints, A0 and C0, with total jump is 1 in the different orbit. Then for the case 2, the derivative of H to the Qn is equal to these 3 values. Now let us consider when they are in the same orbit, when the breakpoints are in the same orbit. So in the case the breakpoints H to Qn alternate in their order. In this case, when they are in the same orbit, the location of the breakpoints are alternating, and we denote by un the closed intervals with endpoints as and a minus qn plus s. So and let me formulate our next main result. Let H be Ehrman's map with 2 breakpoints A0 and a I0 with total jump is equal to 1, which lie on the same orbit, and then the derivative of H to the Qn is equal to these values for when n is bigger than an I0. And just for more information, I gave the sketch of the proof of the case 1. And here, the key role takes the result of theorem 4, which is proved by Ehrman. And here, as I mentioned above, DHQN is constant on the subsets of UN. And UN bar, Sn minus un. So and therefore, this interval we divide the integral we divide to the 2 parts, on the integral on un and integral on un s1 minus un, and we compute we find exact values of intervals in each case, in each part, and the integral on un is equal to this value, and this and here we can see that invariant measure of S1 minus UN is equal to this, because 1 is an invariant measure of whole circle is equal to 1. And from here we get the first result. I just gave just only one case. Just this is just sketch of the proof only for the one case. This is all. Thank you for your attention.
Thank you. So the talk is over. Any questions or comments? Ахтам, считаемся?
Адам Шурдама.
Как там ваше мнение как специалиста?
Хороший. Тут, значит, в общем случае задача ставится так. Если у нас имеется кусочно гладкий гомеоморфизм окружности с иррациональным числом вращением, и там 2 случая, когда произведение величины изломов равно единице и не равно единице. В случае, когда произведение изломов не равно единице, в этом случае мера будет сингулярная. А когда произведение равно единице, вот этот случай оказался трудным. Там была классическая работа Эhrмана для случая кусочной линейки с 2 изломами. Там был фундаментальный результат, что мера является абсолютно непрерывной только в том случае, если они на одной орбите. Ну, вот тут в работе Алишера, значит, он изучает когда две точки излома для отображения Эрмана изучают, значит, как они расположены, точки излома f в степени qn, и далее на этой основе еще используя там фундаментальный факт, что среднее значение логарифма dfqn fh равно нулю, он доказывает, что можно доказать, что для отображения Эрмана классическое неравенство Denjoy превращается в равенство. Это хороший результат, но для случая 2, 3 и так далее, эта задача остается открытой, просто тут сложно немножко. Вычислений много, ну, там, понимать надо, как location breakpoints в этом случае будет труднее. Но задача интересная, как бы, да. Мы идем к тому, чтобы полностью изучить задачу об инвариантной мере, когда много точек излома и произведение величины излома равно единице.
Понятно.
Ну, тут еще появился результат Теплинского недавно. Он доказал, что вот в экзотическом случае, когда 4 точки излома с определенным условием на число вращения, он доказал, что мера будет абсолютно непрерывной. Но вот это уже результат такой своеобразный получился. Мы ожидали, что всегда будет мера сингулярной, если есть точки излома. Вот теперь уже надо разобраться дальше. Ну, тут интересных, ну, они сложные задачи много.
Ясно, спасибо. Marhamat, yana kimda savollar yoki fikrlar bormi? Seminar a'zolarida. Tushunarli. Demak, Alisher ham ISTPda edingiz oldin?
Yo'q, nomlama. Koreyada yo'q juda edi.
Koreyada boshlangan, bu yerda hozir davom ettiryapti ilmiy ishlar. Bizada mustaqil izlanuvchisiz, shunaqami?
Ha, masalan.
Seminar a'zolarida savollar bormi? Yo'q, tushunarli. Rahmat Alisher.
Rahmat sizga.
Demak, Ramziddin she'rdamisiz? Bahrom, she'rdamisiz?
Ha, she'rdamiz Shavkat aka.
Дальнейшее demak, hozir shu oxirgi seminarimizmi bu?
Ha, bundan keyin tugatadigan bo'ldik, ha.
Da, endi regularniy seminarlar to'xtaydi.
Shu oxirgi seminar Denjoy ta'tilga chiqib ketadi.
Nima deysiz? Gapirdimi?
Ha, oxirgi seminarimiz domla.
Oxirgi seminarda. No, endi hali aytganimdek, agar qandaydir mana aspirantlarimizda yoki kimdadir ishlar tayyor bo'lib qo'yishni eshitish kerak bo'lsa, yana navbatdan tashqari bir yig'ilib qo'yishimiz mumkin iyul yoki avgust davomida. Chunki
yaxshi xabar berdi Shavkat aka, ana birinchi parada vaqt to'g'risida.
Kecha prezidium bo'ldi, shunda shu qarorga kelindiki,
Yaxshi bo'ldi.
Mustaqillikni 30 yildan oldin mayli himoya qiladiganlar qilib olsin deb, hozir iyul avgust ham vaqt ishlaydigan bo'ldi.
Ha, yaxshi, yaxshi.
Что biz ham agar kerak bo'lsa yig'ilib yana seminarni очередной yig'ilishini qilishimiz mumkin. Atak regularniy seminarimiz demak birinchi parada ham, ikkinchi parada ham shu bilan tugadi. Mana iyul boshlandi bugundan. Otishga oladiganlarga yaxshi dam olinglar. Qolganlar hammanglar sog' salomat bo'linglar. Shu bilan seminarimizni yakunlaymiz.
Rahmat.
Sog' bo'linglar. Xo'p.
Sog' bo'ling.
Rahmat.
Rahmat.